Good morning, everyone. Thought I would do a video update that would help some people. I'm working on my 69 A100 truck here, and I posted some pictures a while ago on how to rebuild and restore these windshield wiper motors in these things. They're also the same as early A bodies and probably early B bodies, so I think this could be useful to everybody. So when I got done with it, I was all happy. And now that I've got the electrical in the truck, I had it hooked up and it wasn't working. So I had to do some debugging here, and I think this is a good time to explain how these things work so that people can know how to try to fix them, because you cannot buy these things on the aftermarket. You'll have to end up sending it to Topher Guinness or somebody else that restores wiper motors, and most of the time these are pretty easy to fix. There's usually not a lot wrong with them, but if you don't understand electric motors, they can be a little bit daunting. So I'm hoping here I can show everybody how simple they really are and how you can test them pretty easily and figure out what's going on with them. So let's get started. What you'll find when you start working on it is typically you'll see that all of the fiber insulation that they use on these wires is gone or completely disintegrated, and you touch it and it falls off. So half the time you'll find what's wrong with these is the insulation has deteriorated going through the hole here, and they're just shorting out on each other. So I always just pull these apart right from the start and just assume there's bare wires in there that I've got to fix before I turn it on and try to burn it up. So there's a clamp that goes here. I've already got this one apart because I had to fix it. And the wires go in and they're all soldered. There's usually some ancient heat shrink tubing right here. So you have to burn that off, and then you unsolder these. Be careful, this is, there's plastic parts under here, so use as little heat as you can. Have a hot iron that can melt it fast and get on and off as quick as you can. Once you have these wires here disconnected and pulled free, you'll go to the other side where there's two just Phillips or straight-headed screwdriver screws. Pull those off. You'll pull this back, and the armature will be sitting in like so. Your brushes will snap out here. This is more of a weld, so you really can't solder that back on if you break it, so you have to be very delicate with that. Some of these will end up being a little bit tricky because the windings will fold in. So you look and say, I can't get that pulled out through there, but you really can. What I've done is taken some thin sheet plastic sometimes and slid down in here on both sides before I try to pull it out. This one's a little tight, so this one had to get pushed back just a little bit in order to get that armature pulled out. This one, it just pulls right out the back, and the windings are set back far enough that it's not a problem. So once you get that popped off, you can pull the armature out, and then you can wiggle this piece out and pull the wires through. From a wiring point of view, there's only 4 wires that go to these: yellow, red on one connector, blue, and a black, I believe, on the other connector. The yellow and red, when they get over here, what they do is there's a red that flows into this coil. All the windings are wrapped. They come down, come across, wind around the other side, and it comes back up the yellow. So when you're putting it back together, you need to make sure you mark this red and yellow after you take all this cloth material off. And I just use some heat shrink tubing and slide down as far as I can. You'll have no more color on the outside to see how to hook it back up once you put it back together. So you'll have to put little tags on here to tell you which one's the red, which one's the yellow. And when you get done, red is positive, yellow is negative. The other thing to keep track of here is there's a wire that has just is stranded, and you'll see that just runs straight through, and that's the one that goes down to one side of the brush, where I said be careful and don't break that wire off because it's welded to that. The other brush on the other side just grounds to the case. So the case of this is the return for it. The other green wire is actually a solid wire, and it's another field winding in these coils. So you got to be careful when you put this back together that you get all the polarities correct. Like I said, the plus is the red. So the main field that's like a magnet. So today they have, permanent magnet type motors. Here, they're actually just using a current flowing through some iron cores to create a magnet. So this is positive, this is negative, yellow. So if you look at the way this is wired, what you'll see is this black one is the power feed when you turn the switch on. It comes in, and it comes into here, and then it goes into the motor. And if you look at this one that's open, it's this wire right here. And if you look close enough and move these two green ones out of the way, you'll see how they both go into the coil the same way for the red one. And like I said, the red is positive for the field winding. So that means the actual run current coming in the black wire has to be in the same direction. So that's how you know how this all hooks up. These two wires that once you've got your red figured out, and these are much different gauge too, so it's hard to get these mixed up. This is really fine. This is a much heavier gauge right here. But you'll see they both go in and go into the coil right here. So you know those are both plus. You find the red one, you know that this heavier one here that goes into this coil the same direction is your black from your switch over here. Then the rest of them are kind of self-explanatory after you figure that out. So that black one right here, excuse me, goes into the coils, winds through the coils, and actually comes back up this green one. And it comes up right next to the stranded wire one that goes down to the brush. So really, if you take this brush one out, what you've got here is two coils. Red and yellow are your field, goes in the red, out the yellow. And then the engagement comes in the black, which has to go in the same direction as the red, through the coils, and then back out the green. And if you look on the plate, you'll see here's the green fine stranded one. Here is where the other green one was. It now has heat shrink tubing. So you just have to keep those all straight and marked so that when you push this back out through the hole, you can get it all wired back up correctly. Test this, it's very simple. Just ignore that I've got this cover off. That won't matter because we're hot wiring everything anyway. So on the red and the yellow, put in 12 volts in the red, ground on the yellow. Then take your black, because that's your run, put that into 12 volts. Take the return, tie it to the case of the motor, and then all you have to do is take the black that you got hot wired, touch that to the positive, and success, it runs. So the reason we're here right now is because when I rebuilt this the first time and I tried to run it, it would run, but it would have steps in it so that it would turn a certain amount and then it would stall and skip. And then it would turn a little bit more, or one more revolution, and then kind of stall and skip again. sometimes it would stop on that stall spot and never start, and I'd have to go in and just turn the armature a little bit. So I had a spare motor, so I pulled the motor apart. My suspicion was that these armatures are actually multiple windings, and that's what the little slots are here on your slip ring. Is this slip ring goes in, goes through a coil, and actually comes back another slip ring on the opposite side. So that's how the brushes, they touch here. The current will go in this slip ring through the windings, down the other side, out the other slip ring through the brush. So it was pretty clear to me that because it had this rhythmic type stalling, that probably one of the windings in this was shot. If you look at the back, you can see that some of these windings are pretty black. That may or may not mean anything, but in this one, it does. This armature is dead. I really should buy a growler off eBay. If anybody doesn't know what those are, do a Google search. It's something that probably very few people these days even know what it is. So I swapped over the armature into this one, and that's how I got it running. So to put this back together, you take off all this cloth coating and put heat shrink tubing on it. You know, I'd usually take it back as far as I can, or until it stops crumbling in my hand. And then you have to make sure you tag and mark everything, but you need to tag it in small enough tags that you can get it back through this hole in the case here. So once you get that all done, you know, I usually typically bead blast things and make them look nice again when I restore them. So you slide this back down onto your main transmission housing here. You then take your armature, you slide your armature, that'll just slide right into the mesh here if you don't have the gear already out. I will always take it apart and take all that old sticky grease out and clean it up and repack it with some fresh grease. So once you have the armature in there, you'll have to get these brushes in. So there's springs that go in here behind the brushes. So you would slide the spring in, you take the brush, you put the brush in, you push it back, and it's kind of a two-handed and maybe three-handed if you have help, but you need to get them pushed back in with the springs and then push back out. And then I just made this little tool out of it's just sheet metal. It's barely strong enough, but it is enough that once I get the springs in there, I take this, squeeze it carefully, and then do that. That'll hold it, and it's thin enough that once you get this flipped over, everything lined up and put back on like that, the brushes have started. And then you just pop it out like that, push down at the same time, and you're in. You'll notice there's actually a keyway here, so you need to make sure that's lined up on the transmission housing. You'll also notice there's a keyway here, so that you can't get this messed up either. Where is the key? So there's the notch right there. So when you get this in, the keyway lines up. That way the bolts will all line up to the threaded holes in the transmission housing. So once that's all together, that's kind of done, and you'll be at effectively this place right here. You'll solder the wires back on where they need to be. And then the next trick is to make sure you don't mess this up. So this is your parking transmission. You need to make sure this pin, you know, this just goes around, and every time it goes around, it hits this cam and opens up these points. So you need to make sure that when you take this plate and put back on, that you've got that pin in, sorry about that, in this open area. If you put the pin on top of this and you tighten it down, you'll just you'll destroy everything. So make sure that pin is in this open area. So when this turns, it actually turns this. And right there, you might have seen that cam open. So it pushes that cam every time it comes around. So as I said earlier, now we can chat about park. If this is on here and you've got it running with power on the black wire, just a normal running the wipers, and you turn the switch back to off, what the switch will actually do is take power off the black wire and it'll put power on the blue wire. But what happens is, if you remember, this green soft wire goes to the brushes. Typically, it's being powered from that black wire, but the black wire now doesn't have power on it, but the blue wire now does. So it's actually now, the brush is actually getting power from this blue wire up here, going through that switch, coming out the other side, and then going to the brush. When the transmission gets to the point where that opens up these contactors in the back, it breaks the power from the blue wire getting to the brush wire, and now you don't have a field because the switch has already taken it off from the yellow and red wire. This switch now has broken the secondary field from the park position here, and the motor stops in that position. So that's how it parks. So once I get this lined up here, I'll run just a little bit of sealant around here. These really don't need it because they're not out in the elements. They're under the dash on these older ones. So you don't really need that. Put in the screws, put in the wire clamp. It's got the switch hooked back up. The power now just comes in into this side of the circuit breaker, or comes out of this side of the circuit breaker into the switch. The early days, apparently, probably for safety reasons, they thought it would be better that if something happened, you'd have more chances to keep the wiper motor running instead of blowing a fuse and having it open until you change the fuse. They wanted to retry it. Clearly that didn't pan out, and these days if you blow a fuse on your wiper, they just stop. So that said, if your circuit breaker doesn't work, and these are just bimetallic thermal devices, so today they use PTCs, and they have a habit of dying eventually. So if this dies, you can just jump this with a inline fuse. I'd probably use 20 amps maybe. Excuse me. So power goes into the side of the circuit breaker. You need to ground the switch to the motor itself, so there's a ground wire there. And then the negative side of the battery needs to be tied either to the switch or the motor. I've got it just tied into the motor. So that said, let's see how this all works. So this is actually a variable speed switch. The further you turn it, the faster it goes, and it changes the voltage on these yellow and red wires is how this works. And back to off. And there's park. Success. Well, I hope this was useful to somebody. And like I say, you can't get these motors, you can't get these switches, so please do not ever throw them away. So there you go, all done. Time to put it back in. Like I said, these motors and switches are not available aftermarket, so please don't throw them away. There's good parts in both of them. If you don't know what to do with them, send them to me. I'll keep a collection of parts. And maybe someday I'll put a few together and have them available. We'll see how that goes. But if you found this interesting, let me know and I can show you how to go through this switch and restore the switch. Because there's a couple things in the switches that could go bad that are really simple to fix. Once you get them apart, you'll see that they're almost bulletproof. If they haven't been overheated, there's really nothing to go wrong with them other than a couple things which are really simple. So I can go over how to rebuild one of those switches if you found this interesting.